Hello class, this is a video tutorial on solving simultaneous equations, part 2b. In this video, we'll be looking at the elimination method. This method is suited for when the substitution method is not viable. So I'd like for you to compare the equations in this example. Notice how we don't have x or y as the subject, and compare that to these equations where we have y as the subject or x as the subject already. So when we have this format of the question, it's better suited to do the elimination method. Now, as you can see, the steps to this are a little bit more specific. So you can pause and write these down, but I'll demonstrate to you the steps as we go through the example. So here we go. So step 1 is we're going to ensure that all the variables in both equations are in the same order. So for me, I like making it x, y equaling a number. So I'm going to do that to both equations. So for equation 1, 3x stays where it is. Negative 2y is going to move across so that it becomes positive 2y. And negative 2 is already on its own on the other side of the equation, so negative 2. As for equation 2, same thing. I'm going to make it x first, and then y, and 27 needs to move across to the other side of the equation. So 5x goes first, negative y goes second, and negative 27 moves across. So this gives us positive 27. So step 1 is now complete. For step 2, we choose a variable. It won't matter which one. We're going to ensure that the coefficients are the same regardless of the sign. This means 3x and negative 3x are okay in this method. So for this example, I'm going to choose x. Now notice the coefficients of these are not the same. So if no coefficients are the same, we're going to multiply both equations by a factor so that they become a common multiple. In this instance, I know 3x and 5x. The lowest common multiple between the two is 15. So I'm going to multiply equation 1 by a factor of 5, because I know 3x times 5 gives me 15x. And equation 2, I'm going to multiply it by 3. Because I know 5x times 3 also gives me 15x. So multiplying out the entire equation, 3x times 5 gives me 15x. 2y times 5 gives me 10y, equaling negative 2 times 5 gives me negative 10. That's done for equation 1. Equation 2, 5x times 3 gives me 15x. Negative y times 3 gives me negative 3y, equaling 27 times 3 gives me 81. And that is equation 2. Now, as you can see, they are both lined up in matching coefficients and matching order. And now both the coefficients of x are the exact same in this example. But remember, it doesn't have to be positive 15x and positive 15x. You can have this one as a negative 15x. Moving on to step 3. So for this one, we're going to add or subtract one equation by the other equation to eliminate the chosen variable. So in this instance, we chose x, and we've made it so that the coefficients are the same. So now ask yourself, is it 15x plus 15x to give us 0? Or is it 15x minus 15x to give us 0? In this example, it's going to be a minus. Now take a look at what happens. 15x minus 15x gives us 0. 10y minus 3y gives us 13y, equaling negative 10 minus 81 gives us negative 91. And now notice that from step 3, we should always have eliminated the chosen variable. Now on to step 4, it becomes rather obvious what we need to do. All we now need to do is just solve the remaining equation. And then whatever answer we get, we substitute that back into the original equation, and we'll find the other variable. So solving this, to solve this, we just divide both sides by 13. Just grab a calculator here. Negative 91 divide by 13 gives us negative 7. So y is negative 7. We now just need to substitute this back into any equation from this point here. And for this, I'm just going to choose it for this one. So I'm going to substitute it back into our original equation 1. So substituting it there, we get 3x equals negative 2 minus 2 times, and there's our substitution, minus 7. This will give us minus 2 times minus 7 gives us 3x equals 12. And as you can see, x is going to equal 4. And then from there, that gives us the solutions. X is 4 and y equals minus 7, which we can write as a coordinate 4 minus 7. So I hope that gave you an insight into the steps for the elimination method. Hope to see you in the next video where we go through the other examples. Hope to see you then, and best of luck.